In this video, I'm going to discuss about linked list data structure. So before we discuss about what is linked list, let me tell you about the advantage of using this linked list data structure. We all know about an array. It is a linear collection of data elements in which the elements are stored in consecutive memory locations in an array. While declaring arrays, we have to also specify the size of an array. For example, like generally we'll be declaring the size of it, right? Like this 10 or 15, whether the size of the arrays should be 10 or 15 or 100 or 50, whatever. If so, like how many number of elements uh, are the maximum capacity of the array, the size of an array will be declaring over here, right? So we have to specify the size of an array, which will restrict the number of elements that the array can store. For example, if you are declaring the size as 15, like up to 15 elements, the maximum of 15 data elements can be stored, not more than that. But what if when we are not sure about the number of elements in advance? In this scenario, moreover, to make the efficient use of memory, the elements must be stored randomly at any location rather than in consecutive memory locations. So we need a data structure, the better data structure which overcomes all these restrictions. So like the linked list can overcome this all the mentioned above mentioned like which I what are the restrictions which I told now, like the all those restrictions can be overcome by in the linked list, because we no need to the specify the size of an the list in advance over here. And also like it's like the data will be stored in a consecutive memory locations in an array, whereas in the linked list like we can store it does not store its elements in consecutive memory locations, and the user can add any number of elements to it. And also like it allows random access of the data sorry yes, it does not allow random access of data. So the elements in a linked list can be accessed only in a sequential manner, but when it comes to storage, randomly at any memory location wherever like the memory is available, there we can will be able to store, the user can store the data elements in it. So and also unlike like an array, the insertions and deletions can be done at any point in the list at the constant time here. So the only thing is we don't have any restrictions here, because we are not declaring the size in advance over here in the linked list. So we can store any number of data elements in the list. So what is linked list here? It is a linear collection of data elements. Data elements are also known as the nodes. Linked list data structure can be used to implement other data structures such as stacks, queues, trees, etc., and other variations. And also a linked list can be perceived as a sequence of nodes. Like this is how the node structure will be, each and every node structure will be, right? So where each node contains one or more data fields and the pointer to the next field. So any node if you take, mandatorily there must be a data field where we can store the information, and there must be the address field. You can call it as address field or pointer field or next field or whatever. Here we'll be storing the address of the next node. So one field is to store the data, the actual information, and the other field to store the address of the next field. So you can ask me like whether there should be only one data field or only one next field. So it depends upon the type of the linked list data structure which you are going to use. When it comes to the address field, pointer field, if it is a singly linked list, if singly linked list type means there must be mandatorily only one pointer field you are supposed to use. If it is doubly linked list, two address fields can be used. When it comes to the data field, based on our requirement, in any type, respective of any type of the linked list, we can have any number of data fields, depends upon our requirement. For example, I want to store student records using this linked list data structure. If so, like I need to have multiple data fields, right? Like if I want to refer one particular student, I can refer the student using his register number or name or the address or contact number, like multiple fields we have when I want to store one person details. So when it comes to so based on our requirements, like the data field count can be like anything, like it's not mandatory that the data field also should be only one. We can have multiple data fields, depends upon our requirements, and mandatorily if it is a singly linked list, we have to use only one pointer field, right? So and also we can implement a linked list using the following code. Every node, so this is how the node structure will be like this. There will be the collection of nodes will be there in linked list. Now this can be implemented, the linked list can be implemented using the following code. So we are just going to create a node using struct, and in each node we have two fields, one is data field and another one is next field. So this is for data field and this line is for the referring this, the second line refers the next field, right? So after once the node is created, before that I just want to tell how a linked list is maintained in a memory. So just imagine that, okay, I'll make one table now, the representation of the memory. So it has two columns and multiple rows. You just imagine that each and every row is a node, right? So each node, if you take, there must be a data field as well as the next field. The data field will store the actual information, the next field will store the address of the next node, and one start variable which will store the address of the first field. Okay, fine. So let's see how the linked list is maintained in the memory. So you take this example, you just imagine this table. We have two columns and multiple rows. Just imagine each and every row is a node which has two fields, data field as well as the next field, and always there must be one variable which is called start, which will be storing the address of the starting node in the list, because generally okay, I'll the actual linked list structure, the entire list structure with the multiple collection of nodes will be discussed later. So let's see this example first. Okay, when you check the start variable, there is an address 3. So imagine that these are the addresses 1 2 3 4 5 6. This address will be used to refer the corresponding nodes. So under the start variable there is an address 3, which means the starting address of the node in the list is going to be 3, which means the very first node's address is going to be 3. So this is going to be my very first node, but the address is 3. So at the address at the location 3, my very first node is there. So now whatever the process if you want to apply on the data node can be applied. So after processing the data AAA, it has to look at the next field. In the next field there is an address 2, which means after processing the data which is stored at the address 3, it has to go to the location 2 and it will be processing the next data. So the next step is after processing AAA, it has to go to the location 2 and it will process the data, the information which has been stored under the data field DDD. After processing this information, it has to look at it, just check the next node. In the next node there is an address 6, which means after processing this node, the second node, it has to go to the address location 6 and it will process CCC here. After processing this data again, it has to check the next field. In the next field there is an address 5, which means after processing this node, it has to go to the memory location 5 and it will process XXX here. Then again it has to check the next field. In the next field it is null, which is -1, which means it is the last node in the list. So this is how the linked list will be will be processing the data here. So always the starting address will be stored at the start variable. So like after processing each and every the information which has been given on the data field, it has to check the next field. So like whatever the address is specified in the next field, and that is going to be the next node actually. So the order is based on the next field only here in the linked list. So when it comes to an array, all the elements, the data elements will be stored at the consecutive memory locations. For example, this is the array structure 1 2 3 4 5 like that. So like the very first data will be placed at 1, and then again it will be placed at 2 3 4 like that only. But when it comes to the linked list, randomly at any memory location the data can be stored. So wherever the memory is, the space is available, there we can the store we can store the data over there. This is the major advantage here in the linked list data structure. Now when it comes to linked list type, there are a singly linked list, and second one is doubly linked list, and third type is circular linked list. So these are the multiple types of linked list. So when it comes to singly linked list, there will be only one pointer field there. When it comes to doubly linked list, there will be two pointer fields. Again under the circular, there are again two different types are there: circular singly linked list and circular doubly linked list. So we'll discuss all this one by one in my upcoming videos. Thank you.